Today's objective is direct variation and proportion. Direct variation, you have one equation to learn today, and that is y equals kx. In a direct variation, you have y varying directly as x, but this k is a constant. And sometimes you have to solve for that constant so you can create an equation that you can use to solve what you need to solve for. So your first objective is to determine whether each equation describes a direct variation. And I'll leave that up there so you can copy it or read it. And while you're doing that, I can give you a couple of small examples. Usually something like this, y equals 3x. That's a direct variation because remember, the general equation is y equals kx. So all you've done is put a 3 in place of k. That's a direct variation. Y equals x. That's a direct variation. Things like that are direct variations. Items like this, y equals 2 over x. Anytime you get an x on the bottom, then it's not going to be a direct variation. This is direct, that's direct, this is not direct. And we're not even going to get into indirect and inverse and joint and combined variations. All you're doing today is direct. It should be very simple. Is this direct? Yes, that's a direct variation. Is this direct? Yes, yes it is. Just because it's 1/3 in the constant part doesn't mean it's not direct. What about this one? No, it has an x on the bottom. What about this one? Yes. A negative decimal in the constant place is still good. That's a direct variation. The answer to this is no. The answer to this one should be what? No. Okay, so y varies directly as x. Find the constant of variation and write an equation of direct variation that relates to two variables. Y equals 6 when x equals 2. The purpose of this problem is to find the constant k and then insert it back into your general direct variation equation. So here is your general equation, y equals kx, and you insert y and x. So y is 6 and x is 2. Now solve for k. You can divide both sides by 2 since it's beside the k and come up with 3 equals k. Put it back into your general form. If k is 3, this is going to be your direct variation equation. Yeah, this should be an x. That's my fault. I wrote k instead of x. We solved for k, and the k goes into this spot here. That's my fault. Yeah, your general direct variation equation is y equals kx. We need to solve for k so we can put it back into the problem and have our complete general equation to use. So plug in 5 for x. It goes right here. And then plug in 2 for y. And to solve for k, you have to divide both sides by what's with the k and come up with 2/5 equals k. And be certain when you plug it back into your general form, you write y equals 2/5 x. For this problem, you must start with y equals kx, plug in 9 for y and 12 for x. Divide both sides by 12. To come up with 9 over 12 equals k, but are we going to use 9 over 12? No, we got to use 3/4. We have to reduce when we can. So it should be y equals 3/4 x. The general equation is y equals kx, and you're going to insert 8 for y and 20 for x. Divide both sides by 20 to get 8 over 20 equals k, but that's not the answer. What is it? It is 2/5. So you must have y equals 2/5 x. Solve each proportion for the variable. X over 4 equals 2 over 9. If you've forgotten, then what you have to do is cross multiply to solve this. And that is 9x equals 8. Divide 8 by 9. This one you still cross multiply there and there, but don't forget when you go top left to bottom right, that is 5 times the quantity x plus 1, and then 6 times 8 is 48. From there you can solve. 15. Oh yeah, you're right, it's a 15, my fault. It is 15, not 5, but 15 times the quantity x plus 1, and then equals 8 times 6, 48. So 15x plus 15 equals 48. Move the 15 to the right, change the operation to minus 15, and come up with 33. So x equals 33 over 15. Or that's the same thing as 2 and 3/15, which could also be 2 and 1/5. Cross multiply here to get 5 times the quantity x minus 1, and cross multiply here to get 2 times the quantity 3x minus 4. Distribute to get 5x minus 5, and then 6x minus 8. Keep this 5x on the left, move the 6x to the left, change the operation, keep that minus 8 on the right, and move the minus 5 over, change the operation. 5x minus 6x is negative x, and negative 8 plus 5 is a negative 3. Divide both sides by the negative 1 from the left to get an answer of 3. In this problem, concentrate on if y equals 4 when x equals 2. Use this, y equals kx, to plug in that x equals 2 and y equals 4 so that you can solve for k just like we did. Divide both sides by 2 and get k equals 2. That means that your equation is going to be y equals 2x. So once you have that equation, you can go look at the rest of the problem here. Find y when x equals 6. Using this equation that you found, plug in 6 for x. And you come up with a y value of 12. That's all there is to it.